Canavar, your daily reporter. Today we will look at Maryswitch High School, who is currently undergoing a start time transition. We are interviewing 3 different students. Using response bias, we will identify how the format of the questions may influence the students' responses. Welcome back! Our news crew decided on this topic because it is controversial. Students with different hobbies have different opinions on the topic. The first student we will be interviewing is Kelly. Do you support the change in school start time that would force the students to stay in and after school longer and would decrease the time for evening activities and homework?
No, I don't support this. I'm on 13 different sports teams, in 12 different clubs, and on 9 AP classes this year alone. Do you think I have time to sleep in the morning? No, I need to have time for practice and homework.
Kelly does have a good point. Here we have a very sleepy student, Josie K. Wake up, Josie. I have a question for you. Do you support the change in school start time, which would allow students to sleep in and have more energy for class?
Yes, I absolutely support this start time. Today in school, I fell asleep in science, social studies, English, Spanish, never in statistics though. And I just think all of us need more time to sleep in the morning.
I have Scott Larson, a new student who is a transfer who no one has met before. Hello, Scott. My question for you is, do you support the change in school start time next year?
I do. I feel it is good for school to start later because kids need a good night's sleep.
We brought our students back to analyze the results of the data.
To obtain an accurate representation of the population of the 1198 MRHS students, we used the random number generator on our graphing calculators to generate random integers between 1 and 1198. Then, using our school directory, we assigned each student a number between 1 and 1198. With the random integers that the calculator provided, we found the students in the directory that corresponded with those numbers. Our sample was 56 students, 7 girls and 7 boys from each grade.
If the random number generated exceeded the limit of girls and boys per grade, we skipped that number until we had our desired amount of subjects. Then we found the randomly selected students in lunchtime and proceeded to ask them one of our 3 survey questions, which we randomly picked out of a hat, recording the results as we went.
This design was effective because it gave us a random sample with no bias that represented the population as a whole. Without this random assignment, factors such as grade and gender wouldn't have been accounted for correctly. An example of a bad sampling method would have been to only survey one class of senior AP English students. This method would have presented convenience bias.
The benefits of the population sampled was that they were in high school and the affected population. However, the limitation was that no students from other high schools besides MRHS were sampled, even though the rest of the Howard County schools were also being impacted.
One of the main problems we had with collecting our data this way was that it was difficult to find a totally random sample that had no bias, and the way we ended up collecting the data was tedious and took a lot of time. Also, when we asked the seniors, they knew they wouldn't be affected by this time change, so they gave quick, passive answers.
Some improvements that could be made would be not to ask the seniors and instead to ask the 8th graders, because the seniors would be unaffected by the start time change. Also, another quicker and easier way to find a random sample could have been found.
During this project, we learned how to conduct an effective experiment that induces no bias and contains a completely random sample. We also learned that the wording of the question really affects the responses that people give you on certain questions.
Now let's get to the conclusion. It turned out that the wording of the question did in fact affect the outcome of the responses. When asked the neutral, non-biased question, it was nearly even between yeses and nos. Once it got to the first biased questioning, leaning toward the yes answer, there were 3 more yeses than nos. The most dramatic results, however, were for the second biased question that led towards the no answer, where there were 12 more nos than yeses. So, thanks for watching. See you next time.